This is lecture 3E1-2, Implementation and Operation of Clinical Information Systems. And this is another of the lectures that is likely to be more familiar to you because it pertains to the things that we do day after day as clinical informaticians. My name is Tom Payne, and I'm the Medical Director for IT Services at the University of Washington. The content for this lecture shows up in the middle column toward the bottom, and it comprises a fair amount of the core content outline as is appropriate for the importance of this topic. If we drill down into the outline, we can see that 3.5 is Information System Lifecycle, and under that are 5 bullet points that have to do with governance, needs analysis and system selection, implementation, system testing, and system maintenance, all pertaining to clinical information systems. Here are the key topics we'll cover in this lecture. We'll start with institutional governance. We'll move on to methods to define system requirements and to solicit vendor proposals, then to conversion strategies, which is another way of saying go-live strategies. Next, the elements of a system implementation plan, and then the most important really for us because we spend most of our time doing it, and that is the operations and maintenance of clinical systems. So we'll start with the first in this outline, which is institutional governance of clinical information systems. Here's a summary of what we've learned about governance of clinical information system projects over the years. The first point is that it's wise to integrate the governance into existing governance structures. That isn't always the case. Sometimes it's more prudent to build a new one, but in most cases there is a structure in place that can be leveraged for the purposes of this project and for ongoing governance. Second, these projects should be viewed as clinical projects rather than IT. It has such a large influence on clinical care that's the perspective we should keep in mind. IT supports it, but is best not viewed as the leader of this initiative. Thirdly, the leadership for clinical information system initiatives is best derived from existing opinion leaders rather than from those who have technical orientation or the so-called technophiles. So the next question is, where do we fit institutional governance for clinical information system projects into the organizational chart for the organization? We have to consider several roles that would fit into this chart. The chief medical officer, the chief nursing officer, and other chief clinical officers. Then there's a new role over the last decade that is now summarized as CXIO, so Chief Clinical Information Officer, Chief Medical Information Officer, Chief Nursing Information Officer, and Chief Pharmacy Information Officer in some organizations, and other such titles. The third piece to this structure will be those who lead the IT group, so Chief Information Officers. All of these should find a place in the org chart. And here are some models for the relationship between clinical computing leadership and operational leadership. The first model on the upper left shows CEO for the organization, and on the far right below the CEO is the CFO, and the IT director reports to the CFO. This is the way it used to be more commonly, that IT was a subset of the financial part of the organization, and that reflects the history of IT and healthcare. The second model, a little newer, is that there is the CIO, which now has its own position on the org chart, along with other CXOs, the Chief Financial Officer and Operations Officer, and clinician IT individuals often would report to the CIO, since the role of the clinical side of this was subordinate to the CIO. A third model, which you can see in the right of the upper row, is that the clinician in IT, now referred to as CMIO, may have dual reporting relationship to the CIO and to the Chief of Staff or the Chief Medical Officer. And then as organizations merge and join forces, the fourth model is becoming more common, and that has a central leadership structure that serves different organizations, and you can see this reflected as two large branches of this inverted tree, where you have a CEO of different healthcare organizations and an overall system CEO. And often information technology resources are centralized so that they can serve entities of the organization. And somewhere in that chart will be the CMIO that may be a single individual, or maybe there may be several of them, each serving the organization. So the general theme here to the position of clinical leadership in IT is that it's moving up the organizational chart over time. Medical center bylaws typically cover the content of the medical record, including what is in the record, who's permitted to add to it, the responsibility of providers, including physicians, for entering different elements of information, and standards for timely completion. These, by the way, often overlap with the requirements for Joint Commission and other accrediting bodies. The oversight of medical records is typically vested in a committee that has historically been referred to as medical records and is increasingly more commonly referred to as a Health Information Management Committee. So these are the bodies that the bylaws usually designate to oversee governance of the operations of health information technology. Now here's the first quiz in this lecture on governance, and it has to do with legal agreements in health IT. So the first option is A, that BAAs, DUAs, SLAs are all required by HIPAA. B, BAAs are used when a business associate has access to PHI. C, BAAs, DUAs, SLAs are usually formal legal agreements rather than contractual. And last option is DUAs are required before sharing of data between health organizations. So which of these is correct? And the answer is B. BAAs, business associate agreements, are used when a business associate has access to PHI. So this is actually something that you will see about it written about in HIPAA itself. The answer is not A, because a service level agreement is not required by HIPAA. It's not C, because BAAs, DUAs, and SLAs are usually contractual agreements, rather than formal legal agreements. And not D, because DUAs are not required to share information such as discharge summaries or images, which are needed for clinical care. And here's a little more on those legal agreements that might be useful if you're not familiar with these acronyms. BAA, as we discussed, is a business associate agreement that is required by HIPAA. A business associate is someone or some group that has access to protected health information, PHI. A data use agreement governs the conditions for use and sharing of data between organizations. Similarly, data storage agreement has to do with storage. And a service level agreement is typically a contractual agreement that has to do with expectations and agreements regarding performance for support or speed or some other measure. So what sorts of policies are developed by these oversight groups such as medical record committees? Well, several topics are usually addressed. I mentioned before that There are usually rules about who can enter into the medical record as it is defined by the organization. Not just everyone can enter. There are criteria and groups that are considered appropriate for doing so. Alerts are, it's wise to have a central oversight group that makes sure that there aren't 15 groups each adding their own set of alerts without a view of the overall experience of the clinician. There are laws regarding retention of records which need to be followed, and for completion of record, how soon does the discharge summary have to be done, who has to co-sign it, and this group, the Medical Record Committee, is often the group that also monitors these measures' compliance with these policies and presents information at the time of a Joint Commission review. So next we'll move on to the second bullet point, which is Clinical Information Systems Needs Analysis and System Selection. Here's an overview of the methods used for identifying clinical information system needs. So to do this, of course, you need a project team, which you might need to create. You have to define requirements, you have to identify viable candidates, and you have to select a system. So the defining requirements section can be achieved in many ways, including those listed: just observing, mapping, interviews, focus groups, expert interviews. It's not likely that any one individual fully understands all the requirements, and so some technique, some structure to gather these requirements is very worthwhile. And here's an overview of the process for clinical information system selection. It is divided into 5 layers. The first layer is to understand what you want and how to get it, and informally investigate, ask colleagues, go to meetings. Secondly, it may be appropriate to have a formal investigation, which may or may not include an RFP or an RFI, and we'll talk more about this later. Third, one needs to see what it is that you're considering. So this can be achieved in many ways, such as demonstration site visits, calls to others who are using the system, and it should be coupled with a business investigation, which we'll discuss a little bit later. 4, you finally have to make a selection, maybe 1 or 2, a preferred and then another alternative, and then the last step is that you have to negotiate and develop a contract which covers all of the items shown in the white box there: software and hardware costs, implementation services, acceptance criteria, performance clauses, and some protection that the project will be successful. You do need to assess clinical processes so that you'll be prepared for making the right clinical information system selection. To do this, you need clinically savvy people, and that means people who actually work in the domain that you hope to serve. You have to understand the tasks that these people perform and that your workforce performs, including those listed here. It may be your choice to use a formal workforce analysis tool or a less formal approach, but one way or the other, this is complex enough that it should be analyzed and recorded rather than just created from memory or from a single person's perspective. And when you're doing so, of course, you want to consider the offsite work done by clinicians along with that you can actually see on the wards and in the clinics. When the topic of information needs arises in exam, there's a paper that you may want to be familiar with, since it is old enough that it would be fair target for questions on a board exam. And that's a classic paper written long ago by Covell and Manning. What they did was to ask clinicians about questions that arose during their practice, and what they discovered was that for every 3 patients, 2 questions arose, and only a third of those were answered during the visit. So where did the answer come from? On the table at the right, you can see that the most common place that people got their answers was from colleagues, from someone they talked to either in the office or a specialist. They, in those days, referred to print sources, but we would use electronic sources more likely today. And then there are other sources as well. So the point is that there are lots of information needs. These arise every day, and that methods to answer them should be available. It's desirable for them to be available in any case. Right, so here are some formal definitions of these acronyms we've been using, RFP, RFI, RFQ. An RFP is a document that an organization posts to elicit bids from potential vendors. It often includes a weighted point assignment, and that's not required, of course, but it often does so that everyone is clear on what is the most important of the long list of criteria and the relative weighting of those criteria. The RFI is usually made earlier on in the process, where people are just asking for information that can't be identified otherwise, and they may indicate that an RFP will follow, but that is not necessarily the case. An RFQ is when the requirements are more clear-cut and you just want to know what it would cost. In any case, preparing these documents does not create software out of thin air. It helps you in finding out what is in the marketplace that might meet your needs or might not meet your needs. So what's in an RFP? Well, this is from an older article by Kevin Kelly, an attorney who specializes in contracts for clinical information technology. And you can see that the RFP, as you might expect it to, includes a number of different sections. And one is to describe your organization so that those responding to the request know a little bit about you, or actually quite a bit about you. You want to describe your needs, both the functional, the technical, and the business requirements, the timing of the implementation, financial issues such as potential budget range, and then you want to be very clear to lay out the process used to select the vendor, the timeline, and the criteria you will use to make the selection. And of course, if you are using an RFP and it is part of the requirements for your organization, you want to know and conform to those organizational requirements. It's very important that you exercise what is referred to as due diligence in selecting systems. Due diligence is what a reasonable person would do to investigate a business opportunity or a potential licensing of a system. The steps that are often used in exercising due diligence are first demonstrations, which serve several purposes. The first is that they are educational. Secondly, they help bring the group together to involve everyone so that they genuinely feel that they have a stake in this initiative and are they understand the trade-offs in the different options that are in the marketplace. You would want to specify to the vendor that you want to make clear what's there now and what will be there in the future, and if it's a future, when. Site visits are particularly helpful because they allow you to see the system you may be licensing, so-called in the wild, in a place similar to your own, and it's best if you do find places that are a lot like your own. In fact, my general rule is that you want to go to a place using it, ask the people who are tired at the end of the day, maybe about ready to leave, and get their candid opinion about how this system works, rather than concentrate on the PowerPoint presentation by the executives in the conference room. Conference calls are less expensive and they extend your reach, so they can supplement or maybe be the only way that you investigate the vendor, depending on your needs and the system you're investigating. Although these are used for clinical purposes, these clinical information systems really are a big business, and as such you want to know how the business is doing, because it is harmful if you make a contract with an organization that goes out of business. You may be left without a supported application and have to start the process over again. So questions such as how long they've been in business, whether they are privately or publicly held. Are they going to be acquired? If they can be acquired, you never know about the future of that product line by the organization that's acquiring them. You may want to look at their balance sheet to help understand their future, their likely future. And if you aren't facile with investigating balance sheets, you may want to involve someone in your organization who is, such as your CFO or someone in the CFO's office. Contract negotiations are very important because they are the basis for a long-term relationship with your vendor. Because they are so important, it is very much worth considering having legal counsel on your side during these negotiations. You can bet that the vendor will have legal counsel on their side. A lot of organizations include the vendor's proposal in response to your RFP in full as part of this contract, so that things that they said that they are able to do are now contractually included in your agreement. The contract should control the project, the scope of the project, the functionality, the payments, and because of the importance of this contract, one is wise to leave sufficient time to carry out the contract negotiations and sign the contract with enough time to do so properly. It's not something you want to rush through. Many organizations are completely comfortable handling all of this process of the vendor selection and the contract and so on. If the organization does not feel prepared to do this, there are ways to address that need. First consultants are happy to help you. They charge for that process. They're no panacea. And it may be that you and your organization can actually do all of this if you have enough time and find the expertise in your organization. You may have it currently, or you may want to recruit people who have the expertise that your organization currently lacks. The stakes in this process are high. Large, complicated projects with a lot of money involved are riskier historically. And remember when you're doing this that most of the money is not in the initial licensing, it's in the ongoing maintenance. So make sure you pay careful attention to the maintenance portion of the contract. And as I mentioned, legal counsel can be very helpful if you're not experienced and don't have the legal expertise necessary to carry out these negotiations and develop and sign a contract. So next we'll move to the next two bullet points, which are clinical information system implementation and testing. And my guess is that most listening to this lecture have experience in this area, so I will present information in a form that I think might appear on an exam to help you structure your experience in a way that prepares you to be successful in this exam. The overview of implementation is that we start by assessing your current state. How do you do things? What is it that you do? Then you create a design for your future state. That includes designing the software and the workflow, or conforming your workflow to that proposed by the vendor. That's a trade-off that you have to decide about. Then you have to configure the software, you have to test it, and we'll talk a lot about testing because it's so important. You train your workforce, then you convert or go live with the new way to do it. The future state then becomes the current state. You perform an assessment to see how it went, and then at some point, it may be a gradual, it may be an abrupt process, you move this into an ongoing support model. That's a quick overview of the implementation process. So the elements of a system implementation plan are shown here. Project management is increasingly regarded as a very important element of system implementations. You may see people with the title PMP after their name, and that stands for Project Management Professional. Budgeting is very important since a fair amount of money changes hands in these projects. And for that reason, an external audit may be something you want to build into your plan so that anyone who needs to know is satisfied that resources are used appropriately. I mentioned the importance of testing. We'll come back to it. And then also we'll return to training and support. So these are the first elements of a system implementation plan, and we'll continue in the next slide. And in this slide we see that the next elements, which are transition planning. So how are you going to make the transition from the present to the future state? This is also referred to go live or activation or conversion. There are several extremes that you could consider. First is Big Bang, which is all at once. And then the other extreme would be you do it at a very small pilot and you phase it in. And you can do this with many variations. It could be staggered, meaning you start on one and you start on another but before you finish the first one, or sequential, meaning you start and finish in one side and then move on to the next, and so on. Your organization's needs will probably determine whether, if you don't use a Big Bang, whether it's staggered by a particular service line or location, start on one floor, go to the next, or by starting in the ER, start with the surgeons, or location may be a factor. If you're scattered over several states, you may want to concentrate on one state at a time. So all of these options have risks. They have financial implications for the costs, and you're going to need to consider all of that along with the functionality and the geography of your organization. There aren't randomized controlled trials to guide you here. I make reference to an article by Grissom and Chris Longhurst several years ago that kind of reviews the options, but this is really expert opinion at this point. The trend has been that more organizations are using Big Bang than used to be the case, and I think this reflects the maturity of our systems and the large number of organizations who have been through this. And the vendors have enormous experience and can be very helpful here. So now we'll begin the discussion of testing, and I want you to understand some terms that are commonly used that have to do with testing of clinical information systems. The first is unit testing, and this is focused on menus, templates, and modules or subunits of the entire system, and it deals with these separately without regard to their relationship to other elements of the system. The next is application testing, which is all modules or subunits within the application and how they work with each other. So this would be the electronic health record is seen by a clinician. So you have CPOE or an ordering section, a documentation section, results review, and so on. All of these tested together are application testing. But again, we're dealing with that application on its own. We then move into integration testing, which is confirmation that information flow between the EMR and external systems occurs as expected. So, for example, if you have an external laboratory system, do the data flow, the orders and the results flow as you expect them when you connect the EHR to the external laboratory system. Then there's performance testing, which says and really tests whether the entire system with production loads and users functions within expected boundaries for performance. Post-production testing is that you test all aspects of the system now that it's all in production and see that it operates as required. You're likely to have test questions on the testing process, so let's start with an example. First, regarding testing, which statement is the most accurate? And this format, by the way, is something that is fair game. There are statements that all might seem somewhat accurate, and your choice is to pick the one that is the most accurate. A, contingency testing is usually not needed if other testing has occurred prior to go live. B, integration testing assures all functional modules within an EHR system work together. C, unit testing is usually the final step in testing the entire EHR before go live. D, regression testing determines if other components of a system operate after a change is introduced. So which of these is correct? And the answer is regression testing, which I realize I haven't formally defined, but I will. But just so you know, regression testing determines if other components of a system operate as expected after a change is introduced. The first three statements have kernels of truth, but they are not as accurate. Contingency testing is wise to do so that you understand what to do if things go south during the go live. Integration testing is not directed at functional modules, but the connection between the EHR and outside systems. And unit testing is usually not the last step. It's one of the earlier steps in testing of the EHR before go live. So the answer is D. And here are some more testing terms that you are likely to hear, which might show up on the exam. System testing tests all aspects of a given system or application. And you can see the criteria we use in that testing. Regression testing is very common because, again, most of the time you'll be using this system will be after go live. And so you're going to be constantly making changes, putting in upgrades, addressing bugs. And when you do so, you need to test to make certain that, with the exception of the change you're introducing, that all the other components function as they did before, so you don't harm something in your attempt to fix something. Back out or contingency testing tests your ability to back out changes being made if things don't go as planned. And here is even more on testing. The test environment is a domain, that's a term used to refer to an instance of a system, with configuration and data similar to the production setting, and that's the domain in which you do the vast majority of your testing. Scripts are structured simulations of workflow and system use that you can reproducibly use to test versions of the proposed production version. So if you want to do regression testing, then you have a script that shows what happens when you enter an order or you write a document that you can use to test before and after the changes made to your system to make sure that you haven't harmed anything when fixing something else. So scripts are very important. I make the statement here, which I believe, and maybe you do too, that testing is tiring, monotonous, critically important, and it's shortened at very great risk. So even though it is all those bad things, it is very, very important, and you really should learn the easy way, not the hard way. That is something you should be doing. Testing doesn't end after implementation, although it has been performed extensively before implementation. Real-world active surveillance could be considered another form of testing, which is to make it easy for us to identify problems. We need to do more than wait for people to report them, but actually go out and ask or investigate or look for markers of problems. Upgrade testing is something that is more common than go live because there are more upgrades than go lives. Capturing user feedback should be easy. It should be easy for them to provide to you with a button or some simple mechanism or scheduled sessions for hearing their feedback. Safety reporting systems are in place in most organizations and should be adapted and used for users to report problems or safety risks that may be related to the implementation of a system or its operational use. Another form of testing which is used in some organizations, and I think a very good idea, is to, as much as possible, simulate production use. That's very hard to do. And then to use robots that monitor user experience. So you could have a robot set up to order something repeatedly, and if any problem arises from the local network all the way to the production system itself, then the first person to report it is the robot and not a user, which I think is the ideal. Now a few more words about conversion, or the transition to the new system, also known as activation or go live. Commonly, there is a command center, which is a physical on-site presence where all teams are represented. In setting up a command center, one needs to consider logistics, where is it going to be, how large will it be, what workstations are needed, and so on. The command center is a place that minimizes the friction of communication between groups working on the system, because they're all quite literally right next to each other, and it's easy to check if a problem is related to one aspect of the system or another. User support during conversion is critical. The goal is overwhelming support, so-called at the elbow, and we use the term because we want someone as close to the person's elbow right next to them as possible. If problems arise or if they need help, you're there to help it before they become frustrated. Project and non-project team are used often. There are people hired for this purpose. It's wise to consider trainees, medical students, nursing students, and others to provide some level of support so that you can have more individuals in the real world as possible. Roamers are people who just move from unit to unit and see if there are common themes, ask if there's anything they can do to help. All of this is aided by easy communication. So pagers, cell phones, scheduled status calls, shift reports, all of these facilitate communication within the team and between the whole community and the team coordinating the conversion. It's important to have some sort of way to manage the issues or problems that arise during conversion. So you have to have a way to capture it and to triage it. Is it a major problem, minor problem? You document it and you communicate back so that you close the loop. People who report things know that if they do so, they'll hear back about the final resolution or plan to address the problem. This is a great time to review your downtime procedures, because Murphy's Law says that this is the time when a disk drive will fail or some other critical component will go down, and you want to make sure that the whole committee is prepared to follow your downtime procedures if that becomes necessary. We've talked about backout or remediation testing so that you are ready to back out if things don't go as anticipated, and you have a way of addressing the problems that arose and carrying on with your business. There are a variety of models for user training and support that you can choose from to meet your clinician's needs. A common model is classroom training. Web-based training is also used, and blended refers to a mixture of these two. Concierge training really means that you are like a concierge and say, yes, doctor, I'm happy to meet you at 5:30 in the morning to review the use of this new system. Or what time would be convenient? Saturday evening? Yes, we'll be there. So that's obviously ideal if there are varying needs and schedules. It's also more expensive to support. In-person training is, I think, something people respond to a little bit more effectively. We have to be judicious in its use. And also, if you can tailor the training to the specialty, it makes the training seem more relevant to the user rather than having a single training approach that is applied to ophthalmologists and obstetricians and everyone in between. There are a lot of discussions about super users. There's a lot of strengths to this. These are individuals who receive more training in advance to support their colleagues at the time of a transition to a new system or an upgrade. So they are more than users, they are trained to be super users. The weaknesses of this approach are that often the people selected or volunteering to be a super user are also in demand for their clinical role. So they may not have the time to devote to this purpose that everyone would hope that they would. I mentioned earlier that it's very important to be physically present at the elbow as much as possible, and so that problems are recognized and rapidly addressed, or training needs are addressed quickly. More on user support models. There may be a difference between the user support during conversion and ongoing, but don't forget that the problems don't go away when the implementation is officially handed over to operations. The user support may actually rise at that point instead of decline. You have to decide who's going to provide that user support. The help desk, are they going to have the expertise to handle the myriad of questions that arise? Are there going to be people on site, or are you going to use remote methods to support users, which can be very effective? What happens when the first person helping the user is not able to answer the questions or doesn't have the expertise needed, how do they escalate quickly? And you might consider remote viewing of the user experience. So this is used by in health IT and in IT in general, so that you can watch the screen as the user tries to carry out some task and help guide them to the correct way to do so. And finally, the last element of the outline in this lecture is clinical information system maintenance. Now, ironically, this is where we spend most of our time, because most of the life cycle of a system is in maintenance and operations and not in implementation. So we'll move to that next. The topic of operations is a big one, and as you might have noticed, we wrote a book on this very subject. It includes topics that have to do with operating all types of clinical computing systems. The definition is that operations entails the day-to-day running, maintenance, enhancement, and safeguarding of the system to meet the availability and reliability requirements. So this is a big part of what clinical computing groups do, and as a CMIO, this is where we spend the majority of our time. Trends in operations are that many organizations are recognizing that their primary mission is healthcare and health maintenance rather than information technology, and so it's quite common that some operating tasks are outsourced, and one of those might be the operation of the EHR. There are services within the organization that may be outsourced as well. They may be managed by an outside group, such as workstation support. Cloud computing is a general term that is showing up more and more often in health IT. It has the following elements: the provision of dynamically scalable and often virtualized resources as a service over the internet, treated much like a utility. There may be infrastructure, platform, or software as a service. You see the acronyms there. So the networking, or the database itself, the application, the software that you use, such as Word documents or something else, all of these can be provided through a cloud source. It often makes good economic sense because of the scale that cloud computing vendors can offer. And many times people confuse privacy issues and feel that that cloud computing is a security risk, which is, of course, may be the case, but often is the reverse. Now, topics that come up as we implement new systems include what do we do with the older system and the data within it. So do we decommission it? Do we run it at this parallel with the new system? And if so, for how long? The data transfer topics are important because there are costs associated with data transfer, but there are also benefits to doing so. Sometimes people or organizations choose to keep the old system to look up old results rather than transfer them into the new one. The drivers for putting in a new system vary, and for those of you who are in this field long enough, you may remember Y2K, also ICD-10, and many others are meeting meaningful use certification. There are also internal drivers, such as the efficiencies that can accrue when a single vendor system is used in multiple locations rather than using best of breed. As progress is made in the industry, there are often improvements and better systems to choose from. And I often ask people in the board review course how often they replace major systems, and the answers I get vary from about 5 to 10 years. Some have not been in the field long enough to have been through this, but it's becoming more common that systems are replaced within a decade. So you move from one EHR to another, for example. Here's another topic that is wise to know about, and I'll begin this topic with a question. And here it is. The best phrase to describe change control is A, a process for pacing functional change experienced by users when implementing an EHR. B, change control permits assessment of testing and technical features before they are introduced into production systems. C, most consider it a useful but optional step. D, change control is a formal process used to ensure that changes to a system are introduced in a controlled manner. And for the next slide, we'll give you the answer. And the answer is D. It is a formal process used to ensure that changes to a system are introduced in a controlled manner. It is not A. That's an interesting concept and something to think about, but that's not what we mean by change control. Nor is it B. Most consider change control to be an essential step. It is the norm rather than the exception these days. And here is more on change control. This process requires that updates or changes to software, hardware, and other components of the infrastructure go through testing and analysis of their expected and potential impacts. So those who are planning to make the change are charged with making sure that testing occurs, that the impact on the community and on the system is well known, that users are aware this is going to happen, and that you minimize side effects. You can see the formal definition of change control taken from Wikipedia below. And here is an example of a change control checklist that we use in UW Medicine. And you can see that this checklist includes the topics that we've already covered. So this is really a formal way of making sure that each of these steps has been taken before a change is introduced. So there's general information about what this change is and who it will have impact upon. There's documentation that you know that what's going to happen when you put this in, what are you going to do if it doesn't work. Testing, you make sure that you've done all the testing we've talked about and it's all listed there. You've communicated this to the user community and that you're following your own practices for software version control and so on. So this is designed to reduce the risk of a change that you introduce causing troubles or a downtime, which unfortunately sometimes occurs. So let's move to the topic of downtime. Downtime is defined as a system not being available to a significant group, or significant functions are not available, or that performance of the system, even though it's up and running, the performance has degraded below a usable threshold. It is important to plan for downtime since they are going to happen. We divide the world of downtime into downtimes that are planned and those that are unplanned. Here are some premises in the discussion of downtime. First, that all systems will be down sometime. It's wise to prepare in advance for those moments when it is down. Communication, as is always the case in healthcare, is essential. And each of those parties that are involved in downtime must know in advance what to do. So there should be a downtime business plan or policy, and users need to know when to move to that way of doing business. They have to be prepared to do it and be trained to do it. The business must go on. One metric of our success in supporting clinical computing systems is how often downtime occurs, since it is a disruptive process. As I mentioned, we want to develop downtime procedures and train the community to use them, including the new workflow, how they access data and results, they prepare, and whether after the downtime is over, whether we backload those documentation, processes, and orders into the new system, and if so, who does it. We want to schedule downtime optimally so that it fits ideally in the quiet times for clinical activity and key business activities, and that the downtime occurs when both internal and external resources are available. So this is an upgrade that the vendor who might help you with problems is available and prepared to answer your calls. We stratify downtimes by their length and of course by whether or not they're planned or unplanned. If they are planned, it goes without saying that you want to notify the user community well in advance of when this is going to occur and what to do, and remind them about the downtime procedures they should use at the time the system is down. Here is a question for you in the area of operations. True or false? The most common causes of downtime include human error and insufficient system testing of changes. Answer is on the next slide. And the answer is true. There are many causes of downtime, but in every list I have seen, human error is listed as a common cause, and we've already mentioned that another common cause is insufficient testing of changes. And this is why change control process is so important, and you notice in the change control is a checklist for all the kinds of testing that we've discussed. So it seems unnecessary, redundant, but it pays off, and as many areas outside of healthcare have learned, checklists and careful preparation and testing and advanced communication are critical to keeping our systems functioning as we expect them to. So, what are the causes of unscheduled downtime? And by the way, if you know of literature that quantify these causes, I'd appreciate an email. I have not been able to find one. This is derived from anecdotal experience in literature and my own personal experience with UW Medicine for over 17 years. So the causes include human error, a person making a mistake, changes in the system that were insufficiently tested, software failure, hardware or connectivity failure, for example, the network, a disk drive or a buffer reaching capacity, a disaster, unfortunately, and rarely, but on the list, are malicious activity. So all of these are avoidable, but not completely so, and so they do cause unscheduled downtime. And for that reason, we all need to have and follow a plan that includes structured incident command, triage, communication, postmortem review to discover why the downtime occurred and what we can do to reduce the risk of it happening again. So disaster recovery, and I'm sorry to say that some listening to this lecture may have gone through this experience themselves. If you live in an area prone to storms, earthquakes, or other disasters, you may have lived this. Hopefully not. So to define a disaster, we use this definition: unanticipated large-scale loss of clinical computing functionality and or data. Recovery from a disaster it requires our ability to rapidly restore both data and functionality, and sometimes it's necessary to do this off-site, so having off-site storage or remote hosting, having a site that can provide system function will require that someplace has HVAC, power generation, communications as part of this plan, and it is very wise to plan and rehearse these steps and to increase the risk that your recovery from disaster will be successful. So what are the steps that need to occur when your system is down? First on the list would be communication. So you have to have calls, pages, announcements, and let your senior operational management be aware of what's happening to the degree that you can tell them accurately at that moment. The timing of the communication is important. Its content, the level of detail is good to think about. Communication is so important that it may be wise to have a separate group handle it rather than the group that is working hard to restore the system. Otherwise, you end up communicating but neglecting the steps to bring the system back up. You want to make sure that you include in your communications the call to trigger business continuity plans if those plans aren't automatically triggered. And you need to know in advance that all the work area managers for all shifts are aware of the business continuity plan and that they know when to follow them. When you have a downtime, you need a leader and a group. So the leader is sometimes referred to as a general. There has to be somebody in charge. And the group must have time to think broadly about proposed and possible problems and what we could do about it. This may not be the time to find out why the system went down. It's the time to figure out how to get it back up quickly. And just as the case in other is the case in other crises, you want to listen to everybody. The person who is perhaps the least considered to be the least expert may have the right answer, and you want that voice to be heard. All of these people working on the system need to have rest, and they need to be fed. If this system involves a vendor, involving that vendor early, conveying the urgency and escalating within the vendor is wise. When everything is over, it's important to undertake some sort of analysis. It may be a root cause analysis, or it may be some other method, but you want to understand what happened and how you can avoid having that happen again. Now, when the system is back up, you still have work to do. You may have had your workforce write their documentation, their clinical notes on paper, and communicate orders by paper. So the question is, do you put all of those back in the system, or some of them? And if so, who does it, and when do they do it? What about those results that were generated by the systems that were up during the downtime? They are generating lab results or imaging reports and so on. Is there a way for those queued up results to be conveyed to the system now that it's up and running? And that applies also if the laboratory system is down, that you want new ADT transactions and orders to be communicated into the laboratory system. You have to plan carefully for when, or if and when, you switch from orders from electronic to paper and paper to electronic. It may be that for a very brief downtime, you may not make this transition, but for longer ones you will. And understand how stressful all of this is for everyone, and you have to be careful that your team is getting the rest they need. Methods to reduce the risk of unscheduled downtime are listed here. First of all, code updates are very important for keeping the system running and for security purposes. You may not want to be the first site in a big vendor user community to test the latest update. You may let others go first and take your turn sometimes, because sometimes the updates have bugs in them themselves. And you may want to limit the changes that you take to those that are absolutely necessary. That's your call, but you should regularly schedule updates. It may be that you need downtime windows, scheduled elective downtime, optimally scheduled, so that you can do maintenance that isn't possible when the systems are up. And you want to make sure that you communicate all of this so that people are aware there will be a downtime. When you're doing an upgrade, or if there's something major that needs to be done and you may need help, make sure this is scheduled with your vendors so that they're aware of your needs and can schedule their resources to be able to help you. I will mention again the importance of testing, planning, testing, and post-implementation validation. That's where these testing scripts come in handy. And then you want your users to be able to tell you easily if things didn't go as well as we'd hoped, or if problems have arisen. For disaster recovery and downtime, it's wise to consider offsite storage and to have backups, which I think are understood to be essential. It's great to have a backup. It's even better if you can use it to restore your data. So you have to test those restore procedures. There is a risk that in having redundancy, that if there's a database corruption as a result of some data that are entered, that corrupts the database, and if you have two copies, they're both corrupted. So in some organizations, storage is staggered, meaning there may be an hour delay in updating the database. So if corruption occurs in one, you can prevent it from happening in the second one. You want to rehearse downtime, and rehearse it not only for the daytime shifts and evening shifts, but for the night shifts and vice versa. If you have your downtimes at night, you want to make sure that the people who work during the daytime are also familiar with downtime procedures. Sometimes elective downtime is scheduled at the time of daylight savings transitions, but in some cases that happens automatically without a need for special precautions. Here is a term that you likely have heard, but if not, you probably should be aware of. It's called ITIL, which stands for Information Technology Infrastructure Library. It's really a framework for IT service management. It came from the UK back in the 80s, originally designed to reduce costs. It gained much more recognition in the 90s when Microsoft adopted for the Microsoft Operations Framework. What it does is define an organizational structure and skill requirements of an area, and has documents to describe procedures to more effectively manage an IT operation or infrastructure. It's divided into these layers: portfolio, services, processes, and procedures. And we'll go through that in a little more detail. So here is that detail for ITIL. First of all, you have a portfolio, which is high-level, grounded objectives to manage performance, secure assets, manage identities, plan strategically. And that portfolio is made up of services, which are offered to a user or organization with service-level agreements. This would include an expectation that we minimize downtime, we manage performance, protect a perimeter, and so on. And then a service is itself a collection of processes, and they're a collection of procedures using a set of tools by a collection of custodians who does what using what. And then finally you have procedures themselves, which are measured for resource efficiency, and these collections generate the operational metrics. So that is ITIL in a nutshell. And of course, to learn more about it, it requires training, and you may have undergone that training, or you may in the future. Now, communication is so important, and particularly communication with our users, that articles have been written, and I cite one here, that describe processes and mechanisms to obtain and respond to clinician feedback. It is very, very important to have your team embedded in the real world, either using it yourself, members of your team using it, or to be rounding regularly to use the systems to give insights. Remote monitoring is very helpful so that you know what's going on in the entire universe that you support. Feedback button I've talked about before. There's famous papers on the pizza budget, meaning that your implementation budget includes money for pizza so that you can provide meals at feedback sessions, and that increases attendance to the feedback sessions. You want to have a regular pathway for communication with your user community at scheduled meetings, via pages, and being in the hallway and in clinical conversations such as rounds. Now, operating clinical computing systems includes being aware of safety hazards that may be introduced by clinical computing systems. A paper by Walker lists strategies to improve safety of EHR systems, and they include care process transformation, human safety, human factors engineering, software safety, project management, and continuous improvement. So these are 6 elements of strategies to improve safety of EHRs, and you can look at the paper by Walker for more detail. Maintaining clinical information systems includes many activities, but certainly patches or upgrades from the vendor, which I've mentioned before, coding system updates, which may be different from the patches that the vendor provides. If there's a new CPT code set, or we made the transition to ICD-10 recently, drug-drug interaction database, and so on. Maintaining a system includes maintaining interfaces with other systems as you replace or implement systems outside your main clinical information system. You have to develop an interface and test that it works well. And then there are changes in the delivery of the use of your clinical information system to the point of care using end-user devices or something such as Citrix, as we discussed before. All these require maintenance. The term Emr Optimization is common, and when used, it is referring to a post-implementation focus on features and functionality that have been incompletely or suboptimally adopted. It may include a review of workflow and tailored education, and the goal of optimization is to optimally use the EMR to meet organizational quality, safety, and financial goals. Optimization is really a new term for a long-standing effort to continuously improve the use of your system and the workforce's knowledge of how it can be used. Operations includes addressing compliance. Compliance includes many topics, but some of those are the documentation orders, and audit trails are scrutinized by your compliance team to make sure that they are in compliance with regulation, both internal and external, so that you aren't making it easy for users to do things that aren't in compliance. An example of this might be a template that includes a present statement by a surgeon, which might cause trouble since the rule is that there's active entry of a present statement by the person whose presence is being documented. We have lots of focus by the Department of Justice on note cloning and upcoding and copy and paste. And so since in the United States, professional fee bills are supported by documentation, it's an ongoing process to review your documentation process to make sure it complies with CMS and other payer regulation. The legal side of our systems requires attention also. We've talked about the importance of authentication and authorization, and just to review, authentication is proving you are who you say you are, and authorization is now that we know who you are, here's what you can do. The concept of non-repudiation is that if you have entered something into the electronic health record, that we can prove to a jury that you were the one who put it there, and you can't claim that you didn't. Audit trails and documentation version history are frequently called upon in medical legal proceedings, and you will likely be familiar with this if you're asked to give a deposition. It's wise to develop a good working relationship with both your compliance team and with general counsel so that both of you are aware of the need for these systems to support the organization in its goals of being in compliance with the law and in addressing any legal questions that arise in the process of care. And here are a few additional suggested readings. You can see the book written in 2012, which is really targeted for healthcare IT technician and professional certification. It has some excellent elements to it that I think would be wise to review. I mentioned the paper by Grissom and Chris Longhurst on activating the EMR and healthcare informatics. And then there's a chapter by Kevin Kelly in Gretchen Murphy's book on electronic health records, published quite some time ago. There are other references listed in our collection of references for this course. And that ends the lecture.